Okay, so let's just kind of run through the steps again here, guys. If I'm going to write the name of something, I first have to decide whether it's ionic or molecular. Okay, once I've decided that, then I follow the appropriate rules. If I decide it's ionic, I write the name of the metal, then I write the name of the non-metal. Okay, I make it end in I, if appropriate. Okay, I check to see if it needs Roman numerals, okay, because it's got a special multivalent metal. Okay, and if it has a polyatomic ion, then I just write the name exactly as it appears in the table of common polyatomic ions. All right, so we kind of looked at that yesterday, ending off with 8 and 9. Okay, we said this would be calcium sulfate, and that the brackets there were probably unnecessary, but not wrong to have them there. Okay, I have to put them there if I'm doing what? What if I had, what if I had this compound? Would I have to have the brackets there? Yes. Okay, because when I have the brackets in this compound, it tells me I have 1 magnesium and 2 nitrate ions. That would mean 1 magnesium, 2 nitrogen atoms, and 6 oxygen atoms, which is very different than this. Right? Because now I'm saying I have 1 magnesium, 1 nitrogen, and 32 oxygens, which, you know, isn't that much different than the other thing that we wrote. Okay, making sense? All right, so if I didn't need those brackets, it's not wrong to put them there, but this is a situation where they absolutely have to be there. Otherwise, you're saying something you don't mean. Okay, and you can't take it back after that. So, okay, all right. Let's look at number 10. What would the name for number 10 be? Guess what?
Potassium permanganate.
Potassium permanganate. Yep. Okay, it's an ionic compound because potassium is a metal. Okay, and then it's got a polyatomic ion, permanganate. Okay, this stuff was actually used as a fungicide in World War I and II. Okay, it comes as little purple crystals. They're actually quite pretty to look at. And they would put it on, you'd put it on your feet so you wouldn't get, like, you know, fungus infection in your boots and then be painful, get trench foot and all that bad stuff. So that's what they would use it for. It did have a side effect though. If you had fair skin, it would stain your skin. Okay, like you would notice it if you had fair skin. Okay, I had this kid I taught like 22, 23 years ago. He never ever listened to me. Never. And we were going to do a lab, and I said like 3 times, guys, this is the potassium permanganate. Make sure you use the scoop. If you don't, it will stain your fingers. And he's like, comes up to me about 5 minutes into the lab. He's got the whole sample tray, and he's playing around with the crystals in his fingers. Okay? Now the crystals are purple. That is not the color they stain your skin. Okay? So this guy, he was like pasty, okay, like borderline like albino pasty, okay? And he comes over and he's doing this, Mr. Codere, these are so cool. And I just took one look at his fingertips, okay? His fingertips were dark brown. Okay? Like where your finger's been, dark brown, okay? And it doesn't wash off. It has to exfoliate. And it's a deep stain. It's weeks before that goes away. Okay? So he had all around the tips of his index, middle, and thumb stained dark brown for weeks. Thought it would have made him listen better, but no. Okay, so if we ever use that stuff, don't touch it with your fingers. Okay? It's not going to hurt you, but it does leave a stain on your fingers. Okay, number 11. Okay, ionic or molecular? Molecular, okay, nitrogen is a non-metal, okay, so this stuff would be nitrogen monoxide. Oop, that's too many O's. Okay, number 12, ionic or molecular? Ionic, beryllium is a metal. Okay, so what would this stuff be? Beryllium cyanide. 2 metals. Okay, what's cyanide usually used for? Yeah, it's an assassination tool. Okay, it was the king killer for a lot of years back in medieval times. Yeah, that's, if you died by poisoning in medieval times, that was usually the thing that did it to you. Cyanide interferes with the metabolic pathways in your cells. They can't metabolize sugar. If you've been poisoned with cyanide, you just get sleepy and pass out and expire. But you can detect it if you know what you're looking for. It tastes like bitter almonds. So if you ever had like almonds, but they were a little bit stale, okay, that's kind of what it would taste like. If you ever accidentally ingested something, it's like, ooh, it tastes like almonds, but I didn't just eat almonds. You should probably induce vomiting and get that out, because that might be what it is. Okay, and it tastes that way because it was originally harvested from shells of certain nuts. Okay, back in those times, that's how it was developed. Okay, what would 13 be then? Barium cyanide. Okay, what would 14 be? Sodium hydrogen carbonate. What's the common name for that? You've definitely used it in your life, probably in the kitchen.
Is that baking soda?
That is baking soda. Sodium hydrogen carbonate, or sometimes called sodium bicarbonate. Okay, that is baking soda. All right, what would this stuff be? Phosphorus tetraoxide. Anybody write phosphate? Okay, because it's the same formula, right? And that's why I put it on here. Okay, so here's what we want to differentiate. This stuff, if written this way, is phosphorus tetraoxide, but it's an honest mistake to look at that and go, I see it up here on my table of polyatomic ions. Here's why it would be wrong to name it phosphate. An ion can only exist as part of a compound. If it's like that, it's a molecular compound sharing electrons, not something else. If that was bonded to a metal, then I would say it's whatever the metal is, phosphate, but it's an honest mistake, and it's actually why I put it on there. I kind of set people up on that one, okay, just to illustrate that point. If you see something written like this and you see that it's a polyatomic ion, it's not an ion in this case. It's only an ion if it's in a compound with a metal. Does that make sense? Okay. All right, let's have a look at going the other way. Okay, so we've been looking at, I give you the formula, you write the name. Now we got to look at, I give you the name, you've got to write the formula. Okay? Okay, so if I want to convert chemical names into formulas, the first step is still decide whether it's ionic or molecular, because there are different rules for each. Okay? So if I decide the compound is ionic, so let's say I was given this compound here. Okay, so I was given that name and I was asked, write the formula for this compound. That is ionic because magnesium is a metal. All right. So magnesium is a metal, nitrogen is a nonmetal. So my next step then is to write the formula or the symbol for the metal and write its charge up here. Magnesium is a 2+. All right. The next thing I do is I write the formula for the nonmetal. In this case, N. Nitrogen is in group 15, where everything has a charge of -3. Okay, so I write the nonmetal and its charge. Now, remembering Science 9, what do I do with those numbers?
Swap and drop.
Drop and swap, swap and drop. The end result is the same. Okay, so drop the 3, swap it over here. Drop the 2, swap it over here, and I've got my formula. Okay, Mg3N2. The purpose of the drop and swap is to make sure that our positive and negative charges balance. Okay, by doing this, I'm just going to undo those little scribbles I did. Okay, by doing this, I have -3 times 2, -6, and I've got 2 times 3, positive 6. All right, my compound balances up. The drop and swap just makes that happen. Now, is the drop and swap infallible? It is not, okay? Sometimes you might have to reduce the numbers, okay? It happens pretty frequently if I had, let's say, calcium oxide, right? So I would write the formula for calcium, and I would write its charge, 2 plus, okay? And it's with oxygen, which is a 2 minus. If I drop and swap this, I got 2 and 2. Should I leave it that way? No. What if I had 4 and 2?
2 and 1.
Then I would make it 2 and 1. Okay? If you can, it's like fractions. If you can, you reduce. Ionic compounds only. Okay? You would never reduce a molecular compound because the prefixes told you there are this many and they are sharing electrons. In an ionic compound, because they're just balancing charges, it would be in the lowest possible form. Okay? All right. Ringing a bell? Okay. How does this change if I was to get this? What if I got an ionic compound and it had a Roman numeral in the name?
Well, that just tells you the charge that it has in that compound.
Exactly. Without that, I wouldn't know which one to use. Okay, so I would just go, all right, I've got copper, and the Roman numeral tells me it's the 2 plus kind. Okay, it's with nitrogen, which is -3, drop and swap. And I'm done. Okay, so the Roman numeral is there. The Roman numeral tells you what charge to use. What do you suppose the most common mistake is?
People just put like 2 for copper?
Right. They go, oh, copper 2. They see the Roman numeral, they go, that must mean there's 2 coppers. No, it does not mean that. Okay? That Roman numeral tells you this is the charge you use in the drop and swap. Okay? Okay, what if I had, beryllium nitrate. Is that ionic or molecular? Okay, still ionic. All right, so would I still write the formula for beryllium and its charge?
Yep.
Okay. And I would write the formula for nitrate, right?
Yep.
Okay, now here's the trick with that. How do I know what the charge on nitrate is?
The group.
If it was nitride, yes, I would go with the group. Because it's nitrate, okay, I've got to look in here. For all of your polyatomic ions, the charges are listed just above and to the right of them. Okay, so if you just see a dash, nitrate has a charge of -1. Okay, this one has a charge of -2. Okay, -3 for borate, and so on. All right, so I still do this exactly the same. I go, all right, nitrate is a -1, and then I swap and drop. Okay, I don't write ones, so I'm done with that. Right, and no, what do I need? Right. Now I'm done. Okay? It doesn't really change anything. You've never done one with polyatomic ions, but the rules are still the same. Okay? You just have to put a bracket in there so you don't get 32 oxygens or some other crazy number that would make no sense. Okay? Everybody all right with that? Okay. Now, are molecular compounds even easier than this?
Yes.
Yeah, because they tell you what numbers with the prefixes. Yeah, right. If they say it's, carbon monoxide, I know I have 1 carbon and 1 oxygen. Done. Okay? I don't have to drop and swap. I don't have to reduce. I don't have to use brackets. I just have to go, that prefix means 4. Okay? And then I'm done. Okay? So the molecular ones are probably even easier. Okay, so for molecular, write the formula for each element involved in the compound. So if I had let's say I had dinitrogen tetraphosphide. Okay, so I would go, all right, I have nitrogen, and di means 2. I have phosphorus, tetra means 4. Done. Okay, would I reduce that one?
No.
No, I leave it that way. The prefix says 2 and 4. They're sharing electrons. That's how many there are. I only reduce ion. Okay, ringing a bell? There's really not much new in the doing the formulas part from what you learned last year, other than Roman numerals mean use that for the charge, put brackets around when necessary. Okay?
I think I might have lost track of something. What do you mean by reduce?
Oh, so if I was to get, if I had an ionic compound, like let's say I had lead 4 oxide. Okay, so I would follow my ionic rules and I would go Pb 4 plus, oxygen minus 2. When I drop and swap, I get 2 and 4. But I can reduce that to 1 and 2, and the charges would still balance.
Oh, because you can do
Exactly, right? So if I do this, like if I know, sorry, I'm gonna take away my scribbles again there. Okay, so this would be looking like this, but if I wrote it like this, which would be correct, the charges still work out. I've got a 4 plus and a 2 minus, right? That's 4 negatives and 4 positives. The charges balance in the lowest terms. Okay, so the drop and swap might give you bigger numbers, and you've got to look at it like it's a fraction and reduce it down. Okay, but we don't do that in this situation. Okay, molecular compounds don't get reduced. All right. All right, so this is just kind of the quick jot note of those rules. Okay, if you're writing the chemical names, you determine the ionic or molecular, write the name of the metal. So we had that already in the notes. This is just a quick, kind of quick version of it. Okay, and then writing formulas. Okay, that's what we just went over. If you want to write down the quick version of those rules. Okay, I'll give you a couple minutes on that. Okay, so I'd like you guys to try 1, 3, 6, 7, 8, 9, and 11. Okay, let's have you guys try those. I'll give you about 5 minutes or so, and then we'll go through those ones and see how we do. Okay, remember, determine ionic or molecular. Okay, write the, and then follow the appropriate rules. Okay? All right, so our first one, we have calcium phosphide, ionic or molecular? Ionic, yeah, calcium's a metal. All right, so I'm going to write the symbol for calcium and its charge, 2 plus. I'm going to write the symbol for phosphorus and its charge. And then what do? Swap and drop, yeah. So the 3 is going to come down here, the 2 is going to come down here, and there's our formula, Ca3P2. Okay. Questions there? Okay. Don't be afraid to ask, guys, if you got them. Okay. All right, for number 3, I've got manganese 4 oxide. So this one's got a Roman numeral. I only see those in what kind of compound? Ionic. Okay, so manganese is Mn, and the Roman numeral tells me use the 4 plus charge in the drop and swap, and it is with oxygen, which is a -2. Okay, now when I drop and swap those, I get 2 and 4. What am I going to do with 2 and 4? Reduce them, right. It's got to go down to 1 and 2. Okay, and we don't write ones, obviously, so MnO2. Okay, would you get it wrong if you didn't reduce it? You would, yeah. Okay, and not just because it's wrong, but also because if you did it that way in a chemical reaction, you wouldn't be able to balance the reaction properly either, meaning if you were recording masses and things like that, your masses would be way off because suddenly you had twice as much of this stuff as you were supposed to. Okay. Okay, number 6, silver chloride. All right, so silver is Ag, and it's a +1. Okay, chlorine is in group 17, where everything is a -1. That looks good to me. Done. Okay, because we don't write the ones. Okay, number 7, we got a Roman numeral and a polyatomic ion. All right, so we've got copper 2 hydroxide. So I would go, all right, copper, the The Roman numeral is 2, so that's the charge I use. And it is with hydroxide, which according to my table is a -1. All right, am I going to need brackets?
Yes.
Yes, I am. Okay, so when I drop the 1, it goes here. I don't have to worry about that. I drop the 2, it goes here, and then I enclose that in brackets because the 2 is going to apply to the entire ion, not just the last element in it. All right, number 8 is kind of the tricky one because it's going to involve ammonium, which is the only polyatomic ion on your chart that acts like a metal. It's the only one that's positively charged. Okay, doesn't mean I do anything different. Okay, I'm going to have ammonium, which is NH4, and has a +1 charge, and it is with sulfide, which is in group 16, where everything has a -2 charge. All right, I'm just going to drop and swap like I would any other ionic compound. 2 is going to go there, a 1 would go there, but we don't write 1s. NH4 in brackets 2, S. Okay. All right, questions on that one? Okay, so for number 9, we got nickel 2 bromide, right? So nickel and Roman numeral tells me it's the 2+ variety, and it is with bromine, which is in group 17. So it has a -1 charge, drop and swap, NiBr2. All right, and then we got mercury 1 sulfate. So again, we got a Roman numeral that tells us the charge to use on mercury, but we also have a polyatomic ion, sulfate, which is a -2. All right, do I do anything different? Nope, I just drop and swap, okay? 1 would go here, 2 would go here. Can I put brackets on that? I can, it's not wrong, but it's also not necessary, so I'm not going to, okay? But if you had Hg2 and then you had brackets with SO4 inside, that's fine too. All right, how are we feeling about those? Okay, ringing a bell? All right, let's have you try a couple more from here that'll have a few molecular ones in it. Let's go with 15, 16, 17, 18, 19, 20, and 21, and 24. Okay, so if you try those ones, give you a few minutes, and then we'll go through those. Okay, let's have a look at these ones here. All right, so for 15, we've got diphosphorus pentaoxide, ionic or molecular? Molecular, it's full of prefixes, right? Okay, so diphosphorus means P2. Okay, pentaoxide is? 5. All right, done with that one. Okay, aluminum phosphate, ionic or molecular? Ionic. Okay, so aluminum is a 3+, okay, and phosphate is PO4. It's a polyatomic ion, and it's a 3-, I believe. Yeah. Okay. Is that one okay if I just take out the charges? Yeah. Yeah, because they already add up to 0, right? So that would be my formula then. AlPO4. Okay. Could put brackets around the PO4 if you want, but they're not necessary. All right, copper 2 nitrate. Okay, so copper 2+, nitrate, NO3. It's a -1. What do I have to do? Right, I got to drop and swap, and when I do that, I am going to require brackets around the nitrate, so I end up with that. All right, nitrogen dioxide, ionic or molecular? Molecular, yeah, both non-metals, and there's a prefix in there, always a giveaway. Okay, so nitrogen, and how many nitrogens are there? 1. Just 1, right? There's no prefix on it. Okay, and there's how many oxygens? 2. Okay, we're good. Okay, NO2. Phosphorus trichloride, ionic or molecular? Molecular. Also molecular. How many phosphorus are there? 1. Okay, how many chlorine are there? 3. Awesome. Okay, sodium phosphide, ionic or molecular? Ionic, yeah, sodium is a metal. Okay, so I'm gonna go Na, it's a +1. Phosphide is just phosphorus, and it's a -3. What do I do now? Drop and swap. Na3P. Okay, potassium carbonate, ionic or molecular? It's ionic. Potassium is a metal, carbonate is a polyatomic ion. So potassium +1, carbonate, CO3, -2. All right, drop and swap?
Yep.
All right, so the 2 comes here, the 1 would go there, but we don't generally write them, so K2CO3. All right, and then we had ammonium hydroxide. So here's the first one that is ionic or molecular? Ionic, made of
Polyatomic ions.
2 polyatomic ions. Does it change what we do?
No.
Not at all. Okay. NH4, okay, +1 with hydroxide, OH, -1, +1 and -1 add up to 0. Done. NH4OH. Okay. People generally do better on that one if it's this way. I give you the name and you write the formula. If I give you the formula, people mess it up because they see a non-metal first and they're just like, oh, it must be molecular, and they just kind of go crazy with it. All right, remember that ammonium is that 1 positively charged polyatomic ion. All right, I'm gonna have you do a couple more here and see how we do. Incidentally, guys, if you're wanting to practice these or you want to check your answers at home while you're checking them, okay, in Google Classroom, there are keys for all of the worksheets, okay, for all the naming worksheets. So if you go in here, okay, you can go into class work, and you go into worksheets and other materials, okay. Oh, maybe I forgot to put them in there. I thought I did. If I didn't, I will put them in right now. Oh, chemistry worksheet keys, there they are. Okay, so if you go in there, chemistry practice, oh, sorry, worksheet keys, so naming key 2, naming key 1, naming key, they're all there, okay? Just kind of look at which one you're doing and you can check your answers as you go. If you're practicing, how many of these should you do before you check your answers?
All of them. Or all of the ones you're gonna do.
5. Do 5, then check your answers. Okay? If you do more than 5 and you're doing something wrong, all you're doing is reinforcing a bad habit. Okay? I want you to do 5, check your answers. Okay? If you made a mistake, figure out why. Okay? And then don't make that mistake again. All right? But if you do like a whole sheet and then you're like, oh, I forgot for all the ionic ones, I'm supposed to drop and swap. Oh man, you are really cooked at that point. Okay? Because you have just practiced doing it wrong like 50 times. That is going to be really hard to undo. Okay? Do 5, check your answers. Do another 5, check your answers. Okay? All right. Back to this one. Okay, let's do 27, 29, 30, 31, 33, 36. And 38. Okay? All right, so for 27, dinitrogen pentoxide, ionic or molecular? Molecular, lots of prefixes in there. Okay, how many nitrogens? How many oxygens? Right. Okay, for number 29, aluminum nitride, ionic or molecular? Ionic. Okay, so I write Al, it's a 3+. Nitrogen, it's a -3. Does that already add up to 0?
Yeah.
Okay, Aln it is then. Okay, number 30, manganese 4 hydroxide. All right, so manganese, Mn, and it tells me it's a 4+. Okay, and it is with hydroxide. Oh, sorry, 2. It's a 2+. Sorry, I was thinking the other charge. Got ahead of myself. 2+ because I didn't read. Okay, 2+, and it's with OH. What do I do? Drop and swap. Put brackets around the OH, put a 2 outside. And we're good to go on that one. Okay, ammonium carbonate. All right, so ionic or molecular? Ionic, because ammonium is that one polyatomic ion that acts like a metal. Okay, and it is with carbonate, CO3, 2 minus. Okay, when I drop and swap this, what's going to happen? NH4 in brackets 2, yeah.
2.
And then
CO.
CO3. Yeah. Okay, I could put the CO3 in brackets too if I wanted to. Okay, I just don't need a number outside of them. All right, that's about as tricky as they would get, really, unless I, had a multivalent metal in there or something. All right, number 33, antimony 5 sulfide, ionic or molecular? Ionic. Only ionic have Roman numerals, right? So we got SB plus 5 with sulfur minus 2. Okay, so when I drop and swap, I'm going to get SB 2S5. Okay, and number 36, silver chromate, ionic or molecular? Ionic, silver is a metal. Okay, Ag plus 1, chromate, Cr2O7. Cr04, dichromate. Okay. Cr4, and it's a minus 2. Okay. Not one we use very often. Okay, when I drop and swap that one, I'm going to get Ag2Cr04. Okay, that's it. I could enclose the Cr04 in brackets if I wanted. All right, and then last one here, chromium 3 phosphide. Ionic or molecular? Ionic. Chromium is a metal. Okay, so come on. Oh. It's not very happy with me today. There we go. Okay, chromium. Okay, and chromium is a 3 according to that Roman numeral, and it is with phosphide, which is also a 3, just minus 3. So this is just Cr. Yep. Okay, everybody all right with that?
Yep.
Okay. Then I'm going to give you about a 5-minute break here. I'm going to put a few more up on the board. We'll practice those, and then tomorrow I might just throw a few random ones up just to see how we're doing with it, and then we might just move right on. Okay, if you guys are really getting this, then there's not a lot of point to spending a lot of time on it and moving on to properties of compounds and lab reports. Next week we will be doing our first lab on Tuesday. Okay, so we'll sit down with the Chromebooks on Monday, kind of get the pre-lab stuff done, look at what does a lab report look like in high school, what are the expectations of my lab reports and things like that. Okay, all right, take a 5-minute break there, guys, and then we'll get back to something else. All right, so for 47, manganese 2 oxide, ionic or molecular? Ionic, yeah, manganese is a metal and it has a Roman numeral, right? So we got Mn, and it's the 2 plus, it's with oxygen, which is a 2 minus. Does that already add up to 0?
Yeah.
Okay, then we're done. MnO. All right, mercury 2 nitride, ionic or molecular?
Ionic.
Yeah, mercury is a metal. Okay, in this case, it's the 2 plus variety of mercury. It's with nitrogen, which is a minus 3. So that one, bring the 3 down, bring the 2 over, Hg3N2. Okay. For number 50, lead 2 hydroxide. So we got Pb with the 2 plus. Okay, it's with hydroxide, which is OH. That's a minus 1. When we drop and swap, we're going to need brackets with a 2 outside. Okay. Selenium tetrafluoride. Ionic or molecular? Molecular. We got a prefix in there and 2 nonmetals. Okay, so selenium, Se. How many of them are there?
1.
Right. Okay, tetrafluoride. How many fluorines?
4.
Right. Okay, phosphorus pentabromide. Ionic or molecular? Molecular, 2 nonmetals and prefixes. Phosphorus, how many?
1.
Right. How many bromines?
5.
Right. That's a 5. It doesn't look like it, but it is. Okay. Nickel 2 sulfate.
Ionic.
Ionic. Okay, so we got Ni, the 2 plus. plus charge. Sulfate, the polyatomic ion, okay, with a charge of -2. Is that already okay? Yeah, so could put brackets around it, but don't have to. Okay, silicon dioxide, ionic or molecular? Molecular. Okay, so we got how many silicon? 1. And how many oxygens?
2.
Okay, lithium phosphate, ionic or molecular? Ionic. Okay, so lithium is a +1. Phosphate, PO4, is a -3. So when I drop and swap that, the 3 is going to come down here. The 1 is going to go there, but we don't write 1s. Li3PO4. Okay. All right, and then cadmium nitrate was the last one I think I had on the screen there. So cadmium CD. Okay, and what's the charge on cadmium? 2 plus. Okay, and it's with nitrite. Okay, so that is NO2. I believe that's a -1. Okay, so when I drop and swap that, am I going to need brackets? Okay. And the 2 outside of the brackets. Okay. All right. Should you expect to see some where I give you the formula and ask for the name, and some where I give you the name and ask for the formula on Friday's quiz? You definitely should expect that, because I will do exactly that. Okay. So Friday's quiz will have naming. Okay, both kinds, writing the name, writing the formula, and some stuff from lesson 1 on history and structure of the atom. Okay, and so remember yesterday I told you the practice quizzes you'll probably want to look at are 1 and 2. Okay, we may get tomorrow to some of the stuff on properties of compounds. Okay, that's my intention, and to kind of finish that after the quiz on Friday. All right, Monday, lab reports and pre-lab. Tuesday, actual lab. Okay? Okay. What should you do tonight?
Study.
Yeah, I would do at least one of those practice quizzes tonight. Not a bad idea. That way you can come see me for help tomorrow if something's giving you trouble. If you wait till Thursday night, well, then you can maybe jet in here Friday morning, but, okay? It'll be a lot more stressful, I guarantee it. Okay? Try it tonight and come see me tomorrow. Okay, sorry guys, we got 7 minutes. Did I say to pack up? Did I say we were all done? I mean, I know I'm getting old, but I'm pretty sure I didn't say it. All right, I'm gonna have you guys do a couple more like from the other day where it's like formula to name here. Okay, so let's have you do the ones that are on the board, 1 to 9. Write the name. Okay, guys, just so you can kind of check your answers. Obviously, number 1 is sodium chloride. Okay, number 2, potassium fluoride. Okay, number 3, lithium iodide. Okay, calcium sulfates. Okay, aluminum bromide. Oh, that's not supposed to be capitalized. Aluminum bromide. Okay, hydrogen chloride, potassium hydroxide, carbon dioxide, and hydrogen nitrate. Okay, will be the last one there. All right, good work today, guys.